All right, here's our quick lesson on arithmetic sequences. A sequence is any pattern of numbers. And arithmetic means we're going to be adding or subtracting the same amount each time in our pattern. Add, subtract. Okay, so some examples of that would be like 1, 3, 5, 7, right? Our odd numbers are arithmetic because if we look, each time we are adding 2. We could also count backwards, and we could have like 17, 12, 7, 2, right? On this one, we're subtracting 5 every time. That's also arithmetic. Some definitions that you need to know. This amount that you're changing by every time, these are called the common difference. Common difference. We also have the first term is sometimes referred to as A since it's our starting point. So our starting point or our first term can be called A. The last thing that we need to talk about is just about sequences in general. So for sequences in general, some things that you need to know. You're going to see this notation, f of 3 equals 8. Okay, that would just mean that the third term is 8. So if you had a sequence and you had like 4 numbers in it, the third one would be 8. That's all that notation right there means. Also, we can write things. There are 2 different types of rules. So we've got 2 different types of rules. We have explicit, which is something that is written in terms of n. An example would maybe look like f of n equals 2n minus 8. All right, that would be an explicit equation, and that's something that's very easy to just plug in and find a term because you just plug in values to figure out how that one works. And then we also have recursive, and these build on each other. Build. So this is what a recursive one would look like. A recursive sequence might say f of n equals f of n minus 1 plus 7. Okay, the things that you need to know, f of n is the current term, you can see down there at the bottom, and then f of n minus 1 stands for the previous term. All right, so to find the current term, you have to look at the previous term and then do something with it. This f of n minus 1 is like one whole phrase. It's all grouped together. We're not really ever going to plug anything in there or multiply or distribute anything. So you need to know all of those definitions before we move on. Okay, so let's look at how we do this. The recursive rule is actually the easier one to write. Even though it kind of looks complicated, it's the easiest one to write. So I'm going to talk about recursive first. Recursive rules have 2 parts to them. The first thing you have to do is say where you're going to start. So this is my starting point, my A, if you will. So we just say the 0 term, f of 0, is 2. You just have to tell somebody where are they supposed to start counting. And then if we look to find our common difference here, you should notice that you're adding 3 every single time throughout the table. So we say to find the new term, that's f of n is the new term, or the current term, however you want to say that, is the previous term. That's this whole phrase, f of n minus 1. So we take the previous term, and what do we do every time? Well, we said the pattern was to add 3, so we write plus 3. All right, so there's my recursive formula. My explicit formula is something that's going to look pretty familiar to you. For arithmetic sequences, the explicit formula looks kind of like y equals mx plus b, where b is where you're starting and m is how you're moving every time. One thing to note is that b is always the 0th term. Remember, mathematicians are weirdos and they always start counting at 0. So here, I don't have to say where I'm starting because I'm going to say it in my equation. So it's f of n, this is my explicit formula, equals, I'm going to start at 2, and I'm adding 3, because I'm adding 3 over and over and over again, that's where my variable goes, right? So just think about multiplication. This is multiplication, is repeated addition. So this is you just saying you're adding 3 over and over and over again. All right, so those are my, if you were having to write an answer, these would be your 2 final answers for this problem. All right, here we're going to look at how to graph one, and this is one they've actually graphed for us, so I just want to talk to you about the different parts of this problem. So right here, because there is no f of n minus 1, this is an explicit formula. All right, if we were trying to graph this ourselves, we would just plug in values to find where we are. All right, so notice the number that's by itself is my starting point. And remember, we need to start at 0. So they've started, if you notice down here, at 0, negative 1. All right, there's my starting value. The other thing that you want to note here is 2, right, the part that's with the variable, that is what I'm counting by, or my common difference. And because it's positive, that means I'm going to be adding 2 each time. So if you notice, I've started at 0, and then my first term is 2 up from that, and then I'm going to go 2 up from that, 2 up from that to get to my next term. All right, so that's how I'm going to find all those terms over there. The last thing that they might ask you to do is state the domain and range, and I know you all hear domain and range and you kind of freak out for a second, but it's really not that bad. All right, domain are my x values, so if we look here, which x values did they ask me for? Well, they asked me for 0, 1, 2, 3, 4, right? They asked me for the 0 through the 4th term. And then my range is just what the terms are. So here my terms were negative 1, 1, 3, 5, and 7. All right, that's, if you're kind of pushing all of these to the y-axis, you can figure out what your range is. Hopefully that makes even a little more sense with domain and range. All right, here's an example of one that looks a little bit funky. This is how we kind of understand this recursive formula. So they are telling me, first of all, they're telling me to start and make my first term 4. So I'm going to find 1, 4, and that's going to be my starting point. That's my first term. And then what my formula says is that my next term is that previous term minus a half, or I'm sorry, a quarter. All right, so I'm going to actually think in terms of money just to make this easy. They're also going to tell me that I can't use this until I start at the second term. That's why they had to tell me where to start for the first term. So the way we would write this is the second term equals the previous term. All right, so the previous term was, you can even write it like this if you want to. You can say the first term minus 0.25. Or you could say 4 minus 0.25, because that's what the first term was. So that means my second term is going to be, if we think in terms of money, that's $3.75. All right, my third term is the previous term. All right, so that's right here, the previous term. So 3.75 minus 0.25. That's going to give me $3.50. I'm going to do this one more time just so you can see. The fourth term is my previous term. So I got to figure out what the previous was. That was $3.50 minus 20.25, and that's going to give me $3.25. So if we go to plot these, my second term we said was $3.75. My third term is going to be at $3.50. My fourth term is going to be at $3.25. All right, so hopefully you kind of see how to plug that in and how to use the previous term in all of these, how you get where the previous term is from. Again, on these, domain. So domain are the values that I used, the terms that I found. And that was 1, 2, 3, and 4. And then my range are my resulting values. So my range here is going to be 4, 3.75, 3.50, and 3.25. Okay, the last thing we're going to do is model a situation by writing a rule, and I'm actually going to change the directions. They here tell you to write a recursive and an explicit rule. For word problems, recursive is never helpful. All right, if you have to find anything or solve anything, you always need to use the explicit rule. Okay, so this says there are 19 seats in the nearest row, and then each row after the first one has 2 more seats. So the first thing we want to do is just kind of write our sequence. The first one has 19, and each row after has 2 more. So that means the next one's going to have 21, 23, 25, so on and so forth. All right. You also know you just said it because that's how we found those numbers. We're adding 2 every time. How many seats are in the 13th row? Okay, so we need to solve this problem. We need to first write an equation. So the first thing I'm going to do is write an equation, and we want to write an explicit equation. Remember that because we're writing an explicit equation or an explicit rule, we need to use the 0th term. So even though it looks like 19 is the starting point, really we need to think back. If you could have a row 0, how many seats would be in it? Well, to do that, you just kind of undo what you just did, and 17, that's my 0th term. So my explicit rule is going to be f of n equals my starting point, and then I'm adding 2 over and over and over again, so that's plus 2n. All right, there's my rule. Now we want to answer the question, and the question says how many seats are in the 13th row? Well, all that means is I just need to plug 13 in. So to answer our question, so we wrote in our equation, to answer our question, 13th row, we're going to say f of 13 equals 17 plus 2 times 13. And if we just work that out, 26, we're going to get 43. All right, so in the 13th row, f of 13 equals 43. This means in the 13th row, there will be 13th row will be 43 seats. Not too bad. All right, so that's all we've got. Make sure that you have those notes, and we'll see you in class tomorrow.